We are back with some excellent questions based on trigonometry. It is compilation of the most difficult questions which most students could not get in their test paper. Now it is an opportunity for you to understand their solutions and do extremely well. Let us enjoy this journey of learning. Thank you and all the best. You can also watch videos in our playlist, which are amazing. Now let's look into the problem at hand. We need to prove that log to the base 6 of cos to the power of 4a minus sine to the power of 4a is equal to log to the base 36 of cos square 2a. Definitely, we have to change the base. So let's begin with the right hand side. So the right hand side for us is log to the base 36 of cos square 2a. We could change the base to 6. So we have log to the base 6 of cos square 2a divided by log to the base 6 of 36. Now clearly this is log to the base 6 of cos square 2a, right? And 36 is 6 square, and therefore, let me go one more step, doesn't no harm, right? 6 square. And so denominator is 2. So we can rewrite the right hand side as log to the base 6 of cos square 2a divided by 2. Now continuing further, cos square 2a basically is 2 times log to the base 6 of cos 2a, correct? And we have divided by 2, so these 2 cancels. So we have the same base, cos 2a, as you know, is equal to what? We have log to the base 6 of cos square a minus sine square a, correct? But we need cos to the power of 4a minus sine to the power of 4a. Now see, how do we get the left hand side? If I multiply this with cos square a plus sine square a, then will it change the equation? Not at all, because as you know, this expression is just 1, right? However, when you multiply cos square a minus sine square a with cos square a plus sine square a, you get the left hand side. You make sense, right? Which is cos to the power of 4a minus sine to the power of 4a. So that is how we can actually prove this identity. So I'm not, going forward in a new page to continue, since I want the whole solution to be on one screen. So I hope that makes sense, right? So once again, cos square a minus sine square a is equal to cos to the power of 4a minus sine to the power of 4a, difference of squares. Cos to the power of 4a minus sine square a is product of cos square a minus sine square a times cos square a plus sine square a, where cos square a plus sine square a is 1. So that is how we prove it. I hope it makes sense. Here is a test problem for you, a trigonometric equation which involves double angle. We need to provide general solution for this particular equation. Let's see, how do we solve this problem? The question given to us is 2 plus 5 sine, it should be sine x there's a typing error here. 5 sine x equals to cos 2x minus 2. Now, we should write the equation in one trigonometric ratio. So we can write cos 2x, as we know, in terms of sine square x. So cos 2x is 1 minus 2 sine square x. So we get 2 plus 5 sine x equals to 1 minus 2 sine square x minus 2. Bring all the terms to the left hand side, you get 2 sine square x, and then we get 5 sine x. The number, let's write down the numbers, plus 2. This 2 also gets added, and then 1 equals to 0. Or the quadratic equation 2 sine square x in sine, which is 5 sine x now, and here this is plus 2. 4 minus 1 is 3, right? We can factor this. We're looking for a product of 6 and sum of 5, so 3 and 2 can work for us. So we get 2 sine square x plus 2 sine x plus 3 sine x plus 3 equals to 0. So 2 sine x is common. We get sine x plus 1. And here 3 is common. We get sine x plus 1 equals to 0. Taking sine x plus 1 common, we get 2 sine x plus 3 equals to 0. Now that is the factored form which we need to solve. So let's take it to a fresh page. Sine x plus 1 times 2 sine x plus 3. We get sine x plus 1 times 2 sine x plus 3 equals to 0. Now to get the solution, sine x should be equal to minus 1. And here this is not valid, right? As the sine values cannot be more than 1.5, negative or positive, right? So sine x equals to minus 1 is our general solution. How do we figure this out? So let's say this is a sine graph. And it is minus 1 at which point? So you can see sine full graph is that becomes your value when sine x is minus 1, right? So this is, as you can see, 1 pi by 2, 2 pi by 2, 3 pi by 2, right? So as we can see, 3 pi by 2 is one of the solutions. We are interested in finding general solution. So what should be the general solution? So we have x equal to 3 pi by 2 plus 2n pi, right? Because periodic function which repeats after every 2 pi, where n belongs to integers. Okay? We can take pi by 2 common, and we get 3 plus 4n as a general expression for the value of x. So I hope it makes sense. So that is how we can actually find the solution of a general solution for this given equation. I hope it makes sense. Now let's look into the solution of the question, which is sine theta equals to minus cos 2 theta. Now since we have cos 2 theta, we could write it in terms of sine square theta. So what is cos 2 theta equals to? It is 1 minus 2 sine square theta. There are three different formulae, but since we have sine theta, we'll prefer to use this form. Great. So let's rewrite this as sine theta equals to minus 1 minus 2 sine squared theta, which is bringing them all together. 0 equals to, open the bracket. We could write this as 2 sine squared theta. Minus and minus makes it positive. Minus sine theta minus 1. Makes sense. We can now factor this product of minus 2 sum of minus 1, which gives us 2 sine squared theta minus 2 sine theta plus sine theta minus 1. Take 2 sine theta common. From the first two factors, you get sine theta minus 1. We already have sine theta minus 1 as the other factor. So, the factoring is completed when you take sine theta minus 1 as a common factor, and 2 sine theta plus 1 becomes the other factor. Now we are going to apply the zero principle. Each factor should be equal to 0. Makes sense, right? So let's equate sine theta minus 1 equals 0 or sine theta equals to 1. Now sine theta within the interval of 0 to 2 pi is 1 only for pi by 2, right? So we get from here theta equals to pi by 2. The other condition is 2 sine theta plus 1 equals to 0. That means sine theta equals to minus half. To get a solution here, we are looking at a triangle, special triangle, which for pi by 6 gives us half, right? Since we want minus, that means we are looking for angles in quadrant 3 and 4. Related acute angle, alpha being pi by 6. So the solutions are clearly 7 pi by 6 and 11 pi by 6, right? So we get two solutions, which is 7 pi by 6 and 11 pi by 6. Makes sense. So definitely we have three solutions to this particular problem. I hope all the steps are absolutely clear. Cos of pi by 12 minus x times secant of pi by 12 minus sine of pi by 12 minus x times cosecant pi by 12 equals to 4 sine x. So that gives you an idea that we could apply the identity cos a minus b, rather sine a minus b, right? Now, since the left hand side is more complicated, let's begin with the left hand side. We can rewrite secant as 1 over cosine. So what we get here is cos of pi by 12 minus x over cos of pi by 12 minus sine of pi by 12 minus x over cosecant is 1 over sine x, so it is sine of pi by 12. Now let's take common denominator of sine pi by 12 and cos pi by 12. Now we need to cross multiply. So what we get in the numerator is sine pi by 12 times cos of pi by 12 minus x minus cos of pi by 12 times sine of pi by 12 minus x. Clear? Now what does that remind you of? Well, this is similar to sine a minus b formula, right? Which basically is sine a cos b minus cos a sine b. So that is the numerator part. So we can write down the numerator as sine a being pi by 12 and b being pi by 12 minus x, right? So it becomes sine of pi by 12 minus pi by 12 minus x, correct? How about the denominator? Now, denominator has a term sine a cos, which is twice. If I multiply and divide by 2 here, what do I get? Let's do this. We'll multiply and divide by 2. So what we get in the numerator is kind of 2 sine theta cos theta, correct? Which is sine 2 theta. Clear? So there's 2 in the numerator, which I have placed. I'm going to put it here in the numerator, right? And the other 2 combined with sine pi by 12 cos pi by 12 gives me sine 2 pi by 12. So that is sine 2 times pi by 12, correct? Now if I open this bracket in the numerator, I have 2 sine and simplify. Pi by 12 minus pi by 12 is 0 and minus becomes plus x. Here we get sine of pi by 6. Now sine of pi by 6 is half, right? So we get 2 sine x over half, correct? And which clearly is 4 sine x. Is that clear? And that is what you wanted, right? On the right hand side, 4 sine x, right? So we got the right hand side. So we have proven this particular identity, sine pi by 12 minus x secant pi by 12 minus sine pi by 12 minus s cosecant pi by 12 as equal to 4 sine x. See very carefully. First we simplify by writing secant as 1 over cos and cosecant as 1 over sine. Then we took the common denominator, cross multiplied. The expression was same as sine a plus a minus b, and that resulted into the numerator getting simplified to sine x, and the denominator took the form of sine 2 theta. Beautiful question, and I hope you understand the strategy of doing it. So let's see how do we prove this identity. So let's begin with the left hand side, which looks slightly more complicated. It is 1 minus cos 2a. I'm assuming that you have watched some of my videos in the playlist. You know the formula for cos 2a and sin 2a. Great. And over sin 2a. Now cos 2a, as you know, has 3 different formulas, right? Let me show you. First, we could write cos 2a as cos square a minus sin square a. And if I write sin square a as 1 minus cos square a, I can rewrite this as 2 cos square a minus 1. But if I write cos square a as 1 minus sin square a, I could write this as 1 minus 2 sin square a. So that gives you 3 different formulae which are used for double angle, half angle problem solutions. Makes sense, right? Now here on the left hand side, I've got 1 minus, right? So if I have to use 1 minus, it is good to use which one? This is what you need to decide, correct? So I think it is better to use 1 minus 2 sine square a, right? So left hand side, let me rewrite this as 1 minus. And in cos 2a, I'm replacing it with 1 minus 2 sine square a. 1 and 1 will cancel, and that's the whole idea. As far as sine 2a is concerned, only one formula, which is sine a cos a times 2, right? Okay, great. Now if you open the bracket in the numerator, you get 2 sine square a. The denominator is 2 sine a cos a. And clearly, you have 2's cancelling away, 1 of the sine cancelling away, and what remains is Sin A over cos A. So which is tan A, correct? Which is the right hand side. And that is how you prove this particular identity. Extremely important identity with a very simple proof, but may help you when solving very difficult questions. I hope you understand and appreciate selection of our questions. Let us see how do we write cos 2a in terms of tan a. Once again, I am going to use two different strategies to solve this problem, and I'll request you to follow our playlist where we have more than 100 videos on double angle and half angle. Only then you can master these strategies. Perfect. I am Anil Kumar. Welcome to our YouTube channel and the website Global Math Institute. Just in case you want to learn directly, feel free to send email on globalmathinstitute@gmail.com. Our students are right there on the top getting admission to the best universities. Now, let's look into the solution. So, most of you know what is cos 2a. Cos 2a can be written as cos square a minus sin square a. The idea is to write in terms of tan, which you know is sine over cos. So we can always write anything over 1, right? It is still the same thing. That is the basic concept. So here, what we are going to do is we'll rewrite this as cos square a minus sine square a divided by 1 is what? Well, cos square a plus sine square a. And now what we can do is divide both sides by cos square a. And once you do that, what do you get? We get cos 2a equals to cos square a minus sine square a. Both sides means numerator and denominator, right? So we are dividing by cos square a, both of them, right? And in the denominator also, we have cos square a plus sine square a. We are dividing these by cos square a. And what do we get? Well, cos square a over cos square is 1 minus tan square a over cos square a over cos square is 1 plus tan square a. Simple as that. So, if you get this idea of dividing by 1 and replacing 1 with cos square a plus sin square a, this question really becomes very easy. Otherwise, it is difficult to get. However, here's another beautiful method which I want to discuss, and that is we have to write in terms of tan A. So, I'll make a right angle triangle here with an angle of A. Tan A I'll write as equal to t. It means opposite side is t and this side is 1. Since it is a right angle triangle, what is going to be the hypotenuse? Well, square root of 1 square plus t square, right? So let me rewrite this. 1 plus t square. Square root is the hypotenuse. Now what is sine A and what is tan A? Sine A will be opposite side over hypotenuse. So we get 1 plus t square in the denominator with t in the numerator. And cos A will be 1 over square root of 1 plus t square. Makes sense. So we get all the three terms. Now we need to write what is cos 2a. Well, cos 2a, as we know, is equal to cos square a minus sin square a. And from here, cos square a is what? Just square this, right? So we can rewrite this as 1 over square root of 1 plus t square whole square. And sin square is t over square root of 1 plus t square, right? Whole square means this, correct? And now it is 1 over 1 plus t square minus t square over 1 plus t square, which gives you common denominator of 1 plus t square, and the numerator we have 1 minus t square. T is tan, right? So we get 1 minus tan square A over 1 plus tan square A. Makes sense? Correct. So we got the same result, different method. Now, working with such triangles is a very beautiful strategy which can be adopted many times for very difficult questions. In trigonometry, also, when we work with inverse trigonometric ratios, this helps. And substitution in this fashion is a great way of solving many different questions. I hope it gives you a glimpse of what strategies could be. Feel free to write a comment, share your views. If you like and subscribe to my videos, be great. You need to write sine 2a in terms of tan a. One example may not be sufficient to understand all the concepts, and therefore we would like you to watch some more from the playlist. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. In our playlist, we have hundreds of videos for you. Feel free to watch them. Now let's see how do we solve this particular question, which is write sine 2a in terms of tan a. I am going to share with you two different strategies. Here is our first strategy. We need to write sine 2a in terms of tan a, but we know what is sine 2a. It is 2 sine a cos a, right? The idea here is that 2 sine a cos a can also be written as 2 sine a cos a over 1. Do you see that? That helps you to get into tan a form, sine over cosine. So we need something in the denominator that was missing, and this is the key step to solve such a problem. And then what we can do is we can rewrite this as 2 sine a cos a divided by, and what is 1? It is sine square a plus cos square a. Do you see that? At this stage, we can divide both numerator and denominator by cos square a, right? So we'll divide both numerator and denominator by cos square a. So what do we get? In that case, we get sine 2a equals to 2 sine a cos a over cos square a. And here we have sine square a plus cos square a, both divided by cos square a. Simple as that. Now these are all the strategies, not easy to get, especially in a test paper. You see this cos a cancels, and what we get here is 2 sine a over cos a, correct? And here what do we get? Sine over cos is tan square a. And cos square a divided by cos square is 1, and therefore we can rewrite this as 2 tan a over, you can write 1 plus tan square a or tan square a plus 1, right? Right? So, so that is what we get as sine 2a. So I was talking about two different strategies. Let me share with you the second strategy, which some of you might love. So let's think about, we have to write in terms of tan A. So what I'm doing here is I'm making a right angle triangle, and let's say this angle is A. So in this right angle triangle, if I take one side as t, the other one as 1, in that case, what is tan A equals to? Well, tan A is t over 1 or just t, right? So we get tan A as t. So in this right angle triangle, what is going to be the hypotenuse? Well, it is going to be 1 square plus t square square root, right? So now we can write in this particular triangle what is sine A, what is cos A, and what is tan A, we know, right? So let's do it once here. So what is tan A? So tan A is t. Cos A is 1 over square root 1 plus t square. And sine A is t over square root of 1 plus t square. Perfect. Now with that, we get what is sine 2a, right? What is sine 2a? Sine 2a is 2 sine a cos a. So we can substitute the value 2 times sine is t over square root of 1 plus t square, and cos is 1 over square root of 1 plus t square. Now 1 plus t square, 1 plus t square, when you multiply, you get 1 plus t square, right? So this is equal to 2t over 1 plus t square. Correct? Now, what is t? As you know, t is tan a. So we get 2 tan a over 1 plus tan square a. You see how beautifully, just with the help of our right angle triangle, we have got the solution of this particular problem. Correct? You can use this strategy and now write what is cos 2a. So the question for you now is cos 2a in terms of tan a, right? You can follow a playlist with many problems related to double angle, hundreds of them. And if you go through them, at least 10 or 15, you'll master the strategies. Here is a brilliant question based on trigonometric equations. You need to solve for the exact value of b such that cosecant 6b plus pi by 8 equals to secant 2b minus pi by 8. You can pause the video, answer, and then look into my suggestions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. You'll find many questions similar to this to master the strategies. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Now let us take the solution of this problem. Cosecant 6b plus pi by 8 equals to secant 2b minus pi by 8. It was one of the very difficult questions which many students could not answer in their test paper. However, it is based on a very simple concept. So, first, I'll tell you the concept and then it'll be easy for you to understand and solve. The concept is in any triangle, we know co-function identity, right? If one angle is theta, the other is 90 minus theta in a right angle triangle, correct? So, sine 90 minus theta is cos theta. Tan 90 minus theta is cotangent theta. Cosecant 90 minus theta is secant theta. It works both ways, right? Secant 90 minus theta is equal to cosecant theta. Now, since we are given radians, we can also write this as secant pi by 2 minus theta is equal to, or sine, right? So cos theta. And secant pi by 2 minus theta is cosecant theta. Makes sense. So we have to use this particular strategy of co-function identity to solve. Let's use the strategy and find the solution. So now you can easily do it. So basically, we are saying that cosecant 6b plus pi by 8 is equal to secant 2p minus pi by 8. We can write down the right hand side as cosecant pi by 2 minus all this. Imagine this whole thing is the angle theta. So it will be pi by 2 minus 2b minus pi by 8 in smaller brackets. You understand? So once you write like this, cosecant 6b plus pi by 2 equals to cosecant pi by 2 minus 2b minus pi by 8. They can be equated. So we get an equation 6b plus pi by 8 equals to pi by 2 minus 2b minus pi by 8. Makes sense? So now we can open the bracket first and then bring b's together. So 6b, let's say pi by 8 equals to pi by 2 minus 2b plus pi by 8. So bringing 2b to this side, we get 6b plus 2b equals to pi by 2 plus pi by 8 minus pi by 8. Simple. And now we have 6 plus 2 as 8. So we can write down 8b equals to pi by 2. Or b is equal to pi by 2 times 1 over 8 or pi by 16. Makes sense? So that is how we can easily solve this particular question. And so we have the value of b as pi by 16. So that is the solution for the given problem. I hope it makes sense. How do we find exact value of cos pi by 8? We're going to use the double angle formula to find this value. You can always pause the video, answer the question. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Also watch our playlist for many related good questions. Great. Now we need to figure out what is the exact value of cos pi by 8. We know what is cos of pi by 4. Well, cos pi by 4 is 1 over square root 2. Or we also write this as square root 2 over 2, right? Now, cos pi by 8 we can find by using the double angle formula. Now let's look into the double angle formula. Cos of 2 theta is equal to 2 cos square theta minus 1. Now here we can rearrange. We can rewrite this as 2 cos square theta equals to 1 plus cos 2 theta, and then find the value of cos square theta as half of 1 plus cos 2 theta. And definitely cos theta will in that case equal to square root of 1 plus cos 2 theta over 2. Now, in our case, what we have here is theta is equal to pi by 2 theta is equal to pi by 4. And then we can say theta is pi by 8. You get the idea. Now, pi by 8 is less than 90 of pi by 2, right? So it is in quadrant 1. And therefore, we are going to take the positive value. Perfect. So that gives you the background how we are going to find the exact value for cos pi by 8. So it is equal to, so we can rewrite this formula. So we can say cos of pi by 8 is equal to positive value of 1 plus cos of pi by 4 everything over 2 square root. Makes sense, right? Where we know the exact value of cos pi by 4, we'll use square root 2 over 2. Perfect. So let's begin on the next page with the formula we have just derived. So we have cos of pi by 8 equals to positive value of square root 1 plus cos of pi by 4 over 2 square root. So that gives us equal to square root of 1 plus square root 2 over 2, everything over 2, right? Taking 2 as a common denominator, we can write this as 4, 2 plus square root 2. And square root 2 of 4 is, as you know, 2. So we get the answer, which is 2 plus square root 2 square. So that becomes the exact value of cos pi by 8. Perfect. So I hope the steps are absolutely clear. Feel free to write your comments and share your views. Our playlist has many related test questions. Feel free to check on them. Thanks for your valuable time and all the best.